So we're going to talk about measures of spread or variation for this last section of the statistics unit. So a measures of spread explain or display how far the data is spread out from the measure of the center. The measure of spread can help determine what measure of central tendency, like to use mean, median, or mode. All right, so when a measure of spread is high, that means that your data is spread out or not consistent. When I say not consistent, it's not all clustered together. When the measure of spread is low, that means the data is not spread out or is consistent, which means it's closer together. When I say not all gathered, that means like the numbers are like not close to each other. And these numbers are gathered together, which means your numbers are about the same. Okay, numbers gather closely. So when the measure spread is low, the numbers are all about the same. When the measure of spread is high, the numbers are more spread out, okay? So measures of variability include but are not limited to range and standard deviation. You do have other measures of variability. You have MAD, the mean average deviation, and other things like that. You have interquartile ranges, but we're not going to talk about those, okay? All right, so we're just going to talk about the range and the standard deviation. I'm not going to show you how to calculate the standard deviation. I'm always going to have these calculated for you, but we are going to calculate the range, which is very easy. All right, so the range is the difference between the highest and lowest values within a set of numbers or the data. So to calculate the range, all you do is subtract the smallest number from the largest number. That's it. So if I ask you to find the range of this data, the smallest number in here is 24, and the largest number in here is 91. So the range would just be 91 minus 24. So you have 91 minus 24, which is 67. So you have pretty high range, okay? Which means the data is pretty spread out. All right. Let's see if this will act right and it will come up. So I'm not going to talk much about the range because it's pretty simple. Just subtract your lowest number from your highest number. I really want to talk about standard deviation. Standard deviation is a measure of how dispersed or spread out the data is in relation to the mean. This is more so like how spread out is it from highest to lowest value. But the standard deviation really tells you a lot because it's going to tell you how far apart your data is from the average, from the center. So if you have a low or small standard deviation, it indicates that all your numbers are pretty much clustered tightly around the mean. Like you have the mean. If this is your mean, then all the other numbers are like clustered around it. They're not too far away from it. You don't have anything way down here, okay? They're going to be clustered together tightly close to it. All right. And then it says if the standard deviation and range are low, it's good to use the mean because all your numbers are close together. There are no outliers. If the range and standard deviation are high or large, this indicates that data are more spread out and the mean will not be a good measure to use, okay? A high deviation Do not use the mean. A low deviation, then I want you to use the mean. The mean is good, okay? All right, so it says the table shows the points scored by Lucas and Peyton during the last 5 home baseball games. The range of Lucas's data is 1. 5 minus 4 is 1. And the standard deviation is 49 hundredths, okay? However, the range of Peyton's data is 18 because you just do 19 minus 1. And the standard deviation is 7.01. So which measure of central tendency is best to use for Lucas's data? Well, for Lucas's data, I would use the mean. Why? Because all these numbers are close together. Which measure of tendency we use for Peyton's data? For Peyton's data, I'm definitely going to use the median. Now I want you to put something else on A. Let me go back. On A, it has a low range and low standard deviation. That's also an indication that you're going to use the mean, okay? Plus, there are no outliers. All right, so use the median on that one because the range is high. And the standard deviation is high. Okay, and there is an outlier. I mean, 19 is an outlier. The other numbers are 1 and 2. So you're going to use the median, okay? All right. Alyssa and Beverly scored the grades shown below on their last report card. Which girl had the overall higher average? And do you think mean is the most appropriate measure center to use for both girls? Why not? Okay, let's talk about which one had the highest average. So I'm going to take Alyssa's scores and I'm going to add these all together. 93 plus 62 plus 95 plus 94. I'm going to divide them by 4 and see what we get. She's mostly an A student. Plus 95 plus 94 is 344 divided by 4. So Alyssa's average is an 86. Beverly is an all B student. So let's take hers. I know her average is definitely going to be a B. Now I'm going to tell you, Alyssa basically is an all A student, except for one test. But it's saying that she's like a B student. But we know she makes mostly A's. So there's an outlier there, guys. At 62 is an outlier. But let's take a look. Go back to Beverly. 85 plus 82 plus 84 plus 85. All right. So, and we're going to divide them by 4. 85 plus 82 plus 84 plus 85 is 336 divided by 4, which is an 84. So all her numbers are close to or closely centered around the number 84 is what it's saying. This is saying all of Alyssa's are centered around 86, but you can see they're mostly A's, okay? All right, so which girl had the higher overall average? Okay, we're going to put Alyssa. She did. Do you think mean is the most appropriate measure center for both girls? I'm going to put no. It isn't for Alyssa. And the reason why is because 62 is an outlier. The range would be higher. So if you look at the range, you got 94 minus 62. 94 minus 62. 32 is a large range between her grades. Okay, between her grades. It is good for Beverly, though. Using the mean is good for Beverly. All of her data is close together. I'm gonna put all her grades are close together. Okay. And I also had this. I already calculated the mean. The mean was 86 for Alyssa. The mean was 84 for Beverly. The range of Alyssa's was 30. I had 33. Okay, because I did 94. No, it's 95. It's 95 minus 62. I didn't realize I had that down there because I made these notes a week ago. Okay. And then the range for Beverly was 3. The standard deviation for Alyssa was 13.87, and for Beverly was 1.2. And then, you can put something like there's Alyssa also has a greater standard deviation. Beverly has a low standard deviation. But Beverly's is low. Okay. All right, guys, that's it. Thank you.